Welcome everyone. Continuing from the previous topic, that is types of reaction. Second type of reaction which we were doing was decomposition reaction. In the previous video, I told you definition of decomposition reaction. Decomposition is a reaction in which single reactant single reactant breaks down to give simpler products. For example, let us take a very simple example. I'm taking example which I am here taking is in any arbitrary example. Suppose this is a reactant, it is a single reactant. Okay, so what we have to do is that we have to break that reactant. So when we break that reactant, we for breaking that reactant, we need to supply some energy in form of it could be your heat, it could be your electricity, or it could be sunlight. So on supplying these various type of energy, this reactant is going to break down into two simpler product A and B. This reaction is known as your decomposition reaction. So now we have to cover a few important examples. The very first example is the decomposition of ferrous sulfate. Okay, so here FeSO4, it is known as Fe means ferrous, and sulfate, this is your ferrous sulfate. Okay, so on heating this ferrous sulfate, heat, the symbol is triangle, and this ferrous sulfate is of pale green color. Pale green means lighter, it is of lighter color. So when we heat this single reactant FeSO4, then what it happens, it breaks downs to yield Fe2O3 plus two gases, sulfur dioxide and sulfur trioxide. This arrow indicate that these are the gases. After the formation of gases, they're going to escape into the atmosphere. This is your ferric oxide. So on balancing, we get 2 over here. This ferric oxide formed is of brown color. So this is an important example of decomposition reaction in which single reactant breaks down to yield number of simpler products. As you can see that for bringing about decomposition, we need to make use of any sources of energy. Here I am using heat. So second example which is there, that is very common, that is your decomposition of calcium carbonate. This is your Ca means calcium and CO3 is carbonate. It is usually found in marbles or stones which we use at our home. These are found. On heating it excessively, again it will break down to give you simpler product of calcium oxide plus carbon dioxide. This is known as your quicklime. You have side-wise, you have to learn this their common name also. Otherwise chemically it is known as calcium oxide, with the evolution of which gas, carbon dioxide. So this is the second example which we have to cover in decomposition reaction. Third example is your you can see the what is the common in third example is of your decomposition of lead nitrate. This is your lead nitrate. Okay, that lead valency 2 cross over here, nitrate valency 1 crossed over here. So when we will heat this lead nitrate, it will again decompose to simpler product of Pb lead oxide plus gases nitrogen dioxide plus oxygen. So on balancing, we get this ratio. Okay, so now the gas evolved. This is nitrogen dioxide, CO2 carbon dioxide to NO2 nitrogen dioxide. This gas is of brown color. So lead nitrate on heating gives you this product. So if you want to find out something common into our reaction, then which common thing we find is that in all these three reaction we require heat. So those reaction is a decomposition is brought by heating the substance. That reaction is known as your thermal decomposition. Very important. Thermal decomposition. Thermal means heat is required. Now one more example is of decomposition of water. This is a water. So if we have to decompose water, then what we have to supply over here is electricity. So when we supply electricity, then what will happen? It will decompose to yield two gases, that is your hydrogen and oxygen, in the ratio 2:1. So decomposition which is brought with the help of electricity, that is known as that decomposition is known as electrolytic decomposition. Now next is a decomposition of your of silver. We have covered four examples. This is a fifth example of decomposition reaction. A special case is there, silver chloride. So when we have to decompose this, then we can bring its decomposition using sunlight. So when we decompose silver chloride, it decomposes to give silver plus chlorine gas. So on balancing we get this thing. This silver chloride, is of white color, and you know the silver metal is of which color? Gray color. This is an example where decomposition is brought by using sunlight. So this decomposition is known as photolytic. Lytic means breakage, photo means using light, decomposition. Now let's switch to our next reaction, that is your displacement reaction. Displacement reaction, it is a very important reaction. So let us understand this reaction with a very common example. Suppose I am taking over here two reactant A, B and C, and the product formed is AC plus B. Now in this reaction what happened is there this C, what it did, it displaces B from its compound AB to yield AC and B. Those reaction in which one element displaces other element from its salt, the reaction in which one element, you can say one element, that condition is that element must be reactive. If that element is less reactive, then it won't be able to displace other element. The reaction in which one element which is reactive displaces other element from its salt. So this was salt, AB positive, negative, this is a salt. So such type of reaction in which one displaces other, that reaction is known as your, you can say that, displacement reaction. So let us learn it more by catching some example. So example where here I'm taking off, this is iron Fe. If we dip iron nails or iron metal into solution of copper sulphate, this Cu copper SO4 sulphate, this solution is of blue color. Okay, this if iron usually is of gray color if it is not if it is not rusted, then it will be of gray color. So if we add and keep this solution for some time, then what we will observe that this iron is going to attach with sulphate, and copper which is attached to copper sulphate, it displaces out. So the reaction turns out to be ferrous sulphate plus copper. Now ferrous sulphate, we have done this solution is of which pale green color. So that reaction in which one element displaces other element from its salt, that reaction is known as your displacement reaction. Okay. Now the next reaction is double displacement reaction. Double displacement reaction. Since again it is a displacement type of reaction, but here the word uses doubles. So let us first understand what is the meaning of this word double. So again, for making it better understand, I'm taking here AB and CD. These are two reactants. Okay, so they are reacting with each other. The product formed is, let it be CD plus AD. This product formed is, wait, CB plus AD. Suppose this is a product form. So now observe this product carefully. What happened in this product? AB and CD was here. Now what happened? This A is displaced from here and C attached over there. CB and C attached over here and A attached to D to form AD. So such reactions in which there is exchange of ions, between the reactants is known as double displacement reaction. This reaction is usually given one more special name, that is known as precipitation reaction. Why it is given the name of precipitation? Because here precipitates are formed. Let's learn what is precipitation with example. Suppose I'm taking salt of sodium sulphate and I'm adding this into the another salt of barium chloride. Then what will happen? There will be exchange of ion. This Ba will come over here and sodium will go over there. So what will be formed? That is your barium sulphate along with the formation of NaCl. So on balancing, what we look at this equation. So on balancing we get this thing. Now this NaCl, you know very well that it is a common salt. This the salt which is formed barium sulphate. Actually this salt is not dissolved into the solution. This salt settle down at the bottom. So such thing which do not dissolve in which is not soluble, which is insoluble, that thing is known as precipitate. Since this reaction leads to the formation of precipitate, so this is known as a precipitation reaction. And this precipitate is of white color. You have to remember this. These two solutions are of transparent color, and when these are mixed together in equal volume, then the solution which is formed, barium sulphate, is of white color. This white color solution does not dissolve into the solution and it settle down at the bottom. So that's why this is known as precipitation reaction. So one more example we have here to cover. This was the first example. One more example of double displacement reaction we have. The reaction is of lead nitrate. If we mix lead nitrate with potassium iodide, two solution is there. If we mix lead nitrate with potassium iodide, and what will happen? This will come over there and this will go over there. So solution formed is KNO3, okay, and PbI2. So this solution is formed. So on balancing we get this stoichiometry. This PbI2 formed, this is precipitate, means it is not soluble, and this precipitate is of yellow color. You have to remember this. Got it? So this was all about your double displacement reaction. Thank you for watching the video.